afternoon, everyone. Welcome to today's lunchtime lecture in the Climate Action and Sustainability series. I'm very happy to say we're in number 4 of 12. I wouldn't say we're in the home stretch, but I'm hoping for those of you who have been joining us every week are enjoying the sessions, and for those who have joined for the first, I hope you can stay with us for the series as we, I suppose, introduce a range of speakers from Trinity dealing in their own unique ways with climate action and sustainability, and sharing some kind of knowledge and perspectives on addressing national and indeed global challenges. So today is the last of the first 4 of part 1 in the series that has taken us through February now into March, and next week we kick off with part 2 that will take us up to Easter week, where we'll have a 1-week break for Easter break, because I can imagine many people will be in need of a break and may not be able to participate and join us. So with that in mind, part 2 and part 3 will have a bit of a breather, but we're going to go straight into part 2 next week, and I'll share details of that towards the end of today's session. So as always, each session has its own unique focus in terms of supporting our national priorities, climate action plans, and indeed our international focus of, say, the UN SDGs. And perhaps Sarah might indicate where her work is positioned in addressing some of these factors. And today's speaker, it's a great pleasure to invite a colleague from my department who I've been working with for a number of years now, Professor Sarah McCormack, who leads the solar energy research group in Trinity, but has a diverse range of expertise around sustainability and efficiency. And her talk today, I suppose, Sarah, I've partly put a little spin on the title about going beyond ideas, where maybe you'll be delving into this project, the IDEAS project, around integrating and optimizing renewable energy systems in buildings, which is a very important aspect when dealing with climate action and sustainability. So Sarah, thank you very much for joining us. I'm going to stop sharing and let you take over, and we look forward to hearing all about the project.
Okay, let's just see. Are you able to see that, John?
That is perfect, yes.
Okay, so thank you very much, John, for the invitation to give a talk today on integrating and optimizing renewable energy systems in buildings. And I suppose before I start, it would be remiss of me not to say on this International Women's Day, so it's nice to be the speaker for today. And so it's important on days like today that we reflect on the progress that we make and that we have been making in the area of STEM, and particularly in engineering. But it's also a time to think about how we can renew that commitment to trying to create a more just and equitable world for all, and not just women. And from the energy perspective, I was just looking at the stats this morning, and the gender balance is way off there. So we're only about 16% of the workforce in energy is women. So we do have a long way to go, but we're making great progress. It's really important that we continue along that trajectory. So as John said, I'm going to talk to you about integrating and optimizing the renewable energy systems. And first of all, just as he had asked to put our work into context in terms of the SDGs, and from the perspective of energy, it's very obvious, I suppose, that energy fits into the SDG 7 and 11 on affordable clean energy, sustainable cities and communities, and climate action. But actually, whenever you think about the Sustainable Development Goals, energy is the thread through which all of them are linked. So it's really important that we can address energy from a perspective of reducing the amount of energy that we use in the first place, but also in how we generate energy from sustainable means. And this is really important to trying to achieve our SDGs. Often when we see energy and we see our greenhouse gas emissions and how we want to reduce those towards climate action, often this is the type of pie charts that we see. As energy is that thread throughout all of these different energy or greenhouse gas emissions, It's important that we see that for what it is, and that we have the potential here by reducing energy, by changing the way that we generate energy, to reduce those greenhouse gas emissions in that 73% of our greenhouse gas emissions there in total. So it's really important that we see energy as, throughout all of these different areas and sectors that we work in. And from our own national climate action focus, so it's very clearly that energy fits into that powering renewable section. So we have these high targets there. And of course, on the subject today on buildings and how we integrate energy into sustainable energy into buildings, looking at building better. But also, again, it's that thread of energy working through all of the pillars that we see. So how we transform our travel, our transportation, and my colleague, Professor Brian Caulfield, would have spoke to you about that, and even towards making farms more sustainable in terms of energy generation, energy reduction, in greening enterprise and entrepreneurship. And another colleague last week, Ingus, would have talked to you about his work in how he's doing that through energy efficiency measures. And then also through land use, energy is impacting there as well. We may question that in terms of, how does that happen? And when we think about wind farms, that's a way that we're changing our land use. But also now, whenever we know we have these targets for solar energy too, and when we think about wind, so wind currently has about 9 gigawatts, or the target is 9 gigawatts. We have about 4.5 installed. So from our climate action plan, we target to have 9. So we're doubling that capacity. And maybe we won't be impacting on land use there. Maybe it's offshore that we're thinking of. So maybe ocean use or sea use or whatever the equivalent is. But when we think about our targets for solar, so in wind, where we have 4.5 gigawatts moving up to 9, in solar, we don't even have 1 gigawatt, and the target is moving to 8. So this is going to require substantial change in our land use to be able to do that. So while we focus initially on, how do we put them on structures, and that's where my talk will take us today in terms of how we integrate renewable technologies into buildings, but also thinking of the land use for that 8 gigawatts, it's going to take some changes around the landscape as well. And just to put it into a little bit of context, so if we think about 1 kilowatt of energy in terms of installed solar panels will require about 5 meters of our land. So if we're thinking about 1 gigawatt, then that's going to require 5 million meters squared. If we need 8 gigawatts, that's going to require 40 million meters squared. So that's 40 kilometers squared that we're going to need to cover to reach that 8 gigawatt target. So just to give you some idea of how that looks, if you think about a 6.3 kilometer by 6.3 kilometers square, that's essentially the area that has to be covered. So it's going to require some of our land use change, and it's important that we can understand the impacts of that too. But that's not the subject of the talk today, but it is something to think about as we move forward in terms of our energy transition. And when we think about our renewable energy systems, generally, we think about these large installed systems. There's Ardnacrusha there, and our hydro plant, we have wind farms all over the country. Solar farms are starting to appear around us. And then the future plan for wind is to go offshore. And the nice thing about renewables is, when we think about it from a buildings perspective, is that they are scalable, so that we're able to reduce the scale to fit on our buildings. And that's a nice thing with things like solar photovoltaics, where you're generating electricity, where you're generating heat in terms of solar thermal from our geothermal systems, and then even in terms of wind, where you have these very small wind turbines that are able to generate energy to a much smaller extent, obviously, than our large our turbines. So we need a lot more of these systems, and so we need a lot more of these areas and these buildings to be able to generate this energy. And as we move forward in terms of these systems, they can help us in terms of cost reductions, in terms of on-site generation, distributed generation, so we don't have to have these large transmission and distribution networks. We can think about energy independence. So where we have, now we have our local generator. We are in some way hedging our bets in terms of our electricity and our heating supply in the future. We're able to have some independence from the grid. And also, of course, we're reducing our climate and our carbon emissions. And this is where it's helping us to reduce that energy efficient, that energy in buildings, a target that we have. But before we think about energy in our buildings, it's important that we think about the design first. So looking at building orientation, how can we maximize the free solar gains that we have here? So whether it's facing the building south or southeast, looking at how we can ensure that we have a very energy efficient building envelope so that we're not losing any of that energy in terms of our walls or roof or windows or doors, ensuring that they're all playing their part in terms of creating that very airtight building envelope. Green roofs and walls can also help in terms of improving insulation and natural shading. And then, of course, daylighting. So it's trying to ensure that we're maximizing the amount of that daylight into our buildings. That's minimizing then the need for that artificial lighting. And again, another requirement on our electricity generation. So we can use things like skylights into our buildings, light shelves and solar tubes to try to enhance that daylight deep within our buildings, and try to ensure that we first create this energy efficient building, and then we can look at our renewable energies. So then we need much smaller systems in our building, of course, and that's helping in the overall outcomes and towards our climate action. So that brings me to our ideas project then. So in terms of the ideas project, it's looking at integrating renewable energy systems, these different types, into buildings, and trying to see how we can work together towards creating an optimized system for buildings, whether that's in Ireland, whether that's in Italy or France or Spain or wherever. So you're taking advantage of the natural energy flows in the region first and trying to optimize that. So this is the project. It's 14 partners, and they're from all around Europe. It includes university partners as well as industry partners, and it has research institutes and it has community groups as well. So it's a diverse range of people involved, and we have 2 demo sites as well. So one site is over in Westport in Mayo, and the other site is in Ferrara in Italy. So again, we're trying to ensure that we're having the demonstration of all of these technologies in 2 buildings in 2 different locations so that we're able to have different optimization and control techniques for both of these systems. So the IDEA system, it takes up or it looks to develop photovoltaic technologies, integrating them with solar thermal, along with thermal energy storage techniques. Then along with that, it's looking at geothermal and air source heat pump technology. And this is all coupled with underfloor heating. So in terms of the systems that we're using, it's generating electricity, but also generating space heating within the building. And then, of course, not quite necessary in Mayo, but in terms of cooling, we have cooling then options for the demo site in Ferrara, which is obviously necessary there in the summer, but sadly not so necessary in Westport. So we look at these and we try to see how we can enhance the overall efficiencies by combining all of these systems together. So what we generally find when you install a photovoltaic system, for example, or solar thermal, or a heat pump, is that they all have their own individual control systems, and you're all managing them individually. Whereas with this idea, it's around how can we integrate these systems so that they're actually talking to each other? How can we use the solar resource to power the heat pump? How can we use the thermal energy within the solar panel? First, maybe to integrate it into the heat pump, or also how can we integrate it into that thermal energy storage in the floor as well? So which is the best use of that? Is it better to use it for heating or for cooling? And those are decisions based around the climate and the location of the project. So the dependence then in terms of the different types of technology that's used, it really depends on the region, depends on the season, and depends on the time of day. So we have different demands and different requirements depending on where we are. And we also have different sources or different energy supply, I suppose, depending on where we are as well. So if we have a large amount of solar gain in the summertime in Italy, we would have still a good solar gain in Westport, but obviously it wouldn't be as high as that in Ferrara. But then again, in Ferrara, we need that electricity for cooling, whereas in Westport, we don't. So again, it's optimizing the demand, optimizing what generation supply is needed, depending on the demand at that particular point in the day. The two demo sites, as I said, so this is the Drummond Brackloon Community Centre in Westport and Mayo. They're very kindly, the community group there has let us in to really take apart their community centre and put it back together. And we're working with Mayo County Council on that, and they're heavily involved in the installation and implementation on that site. And then we have the larger demo site is in the University of Ferrara in Italy, and that's around the snack bar. So essentially it's the university campus snack bar in the Ferrara University. And it is really what they've allowed us to do there has been amazing. And it is quite an old campus as well, maybe not as quite as old as Trinity, but it is very old. And they've allowed us to dig up large areas of the land to put in geothermal heat pumps for the snack bar itself. And so the development there has been quite phenomenal. So it's quite interesting to see how it all works. But obviously they need a much bigger system there because they have a much higher demand compared to, say, for example, the community centre in Westport, which wouldn't be used all the time. So the demand is much lower there as well. So in terms of the project, then it's looking at the energy storage techniques. So trying to see how, while we have these generators, these electricity generators and thermal generators, how we can actually store that energy when it's available for use at a time when it's needed. So we're combining that with the flexible renewable energy supply to try to cover as much of that electricity heating and cooling needs as we can within the building. And after that, then it's looking at the control around that, so automating how that's done in terms of managing the storage there, and also looking at the supply. So we're trying to see what's the demand at the moment, but also actually what can we predict in terms of the demand in the future, and can we look towards the weather to see what will be the supply within the next few days, so we can start to plan our automation and control techniques within the systems itself. So it starts to become a predictive tool as well, so you can actually manage your overall systems within the building too, depending on what your plans are for the next week or so within the building. And of course, because it's a renewable or a European project funded, it has to be through innovation as well. So it's not just putting solar panels on buildings and solar thermal panels and buying heat pumps and putting them all together and creating the control system, which would have been tough in any case. But actually what we're doing in this project is we're looking at all of the different elements within the project and trying to see how we can innovate within those elements towards new technologies, trying to improve the efficiencies, improve overall uptake in terms of this technology too. So from the perspective of the technologies, the solar part, so as John mentioned, the work that I do here in Trinity is based around solar energy and solar applications. So we're looking at how we can enhance the technology from a solar perspective. And then and the work that we're doing in that is through luminescent materials and how we can enhance the capture of diffuse light. So this is work, as Angus would have mentioned in his talk before about his journey through research towards development and product. So here, this is work that was funded through the ERC, the European Research Council, looking at how we can develop solar devices for buildings. So we used some of that work that was developed there, and we brought that into this ideas project to see how we can actually now implement them into buildings. So this was looking at the different times of the day and trying to see what type of layers that we could make to capture capture light at particular times of the day to make it more efficient. So it's a purely optical approach. You can see there, that's I think that's Bill, one of the PhD students, that's his fingers showing you his nice luminescent layer. And these layers were then, you know, they were characterized. We worked with the university in Portugal, in Spain, and Leitat and Lenig to develop these layers, which you can see. First of all, the top photo there is just our string of photovoltaic cells. And then at the bottom, you have the cells with the layer on top. And essentially what it's doing, it's trying to capture the light that the solar cell can't use. And that's usually around the UV range. And it's trying to use downshift that into regions where the solar cell can use it. So essentially it's moving it from the UV into the visible range. And that's where you're able to collect it and generate, and the solar cells are able to generate more efficiently then in terms of their production. So that was one part. Another part of the system was the thermal energy storage part. So we were trying to create a photovoltaic and a thermal panel in one. And this material was used as a phase change material. So if you can see the graph there, you can see the blue range, it's this sensible heating. And then you have this flat region of the graph, and that's essentially where you have the latent heat storage, which is just where we have an increase in temperature, but actually the temperature of the material is not increasing. And you have the storage potential in the material, and that's what we're trying to take advantage of in this new technology. So we use this phase change material, and the University of Ulster developed some nice biomimetic concepts to try to enhance the heat transfer within those systems. And these containers essentially were placed on the back of our panels or on the back of our solar cells that had our luminescent layers. The other part then was the CPC, which is a compound parabolic concentrator. And that's like a large reflector essentially. And Anita, one of the PhD students, she would have designed and fabricated this larger panel then. Essentially what that's doing, it's trying to capture diffuse light and over a particular aperture of the cell, of the incoming light. So essentially it's designed specifically for the location, and this one is for Westport, and then there's a new CPC would be designed for the systems in Ferrara. So that's the solar element, and here you can see the Brackloon Drummond Community Centre. The panels are there on the facade, and here you can just see a better picture there. So on the left is the installation in Ferrara, and on the right is the installation in Westport. So if you're ever around Westport, Drummond, Brackloon, you should be able to see those panels on the side. So in terms of the system then, we then integrated that part of the system. So the phase change material, the heat that was coming from those panels was integrated into our thermal energy storage in terms of our water tanks. Another way of storing thermally was through this type of phase change material again, but a different temperature range. And these were placed in the floor. So this was along with underfloor heating in the building itself. Just to give you an idea, first of all, we went in, the floor had to be taken apart, and then these containers of phase change material were placed onto the floor. You can see the pipe network there in the normal underfloor heating way. We had the screed on top, and as it dried, then we were able to put the wooden floor back onto the surface. The community centre, one of the important roles that it plays in the community is it has music and dancing every week. So it was critical importance whenever COVID ended that we were able to leave the floor back in its original condition so that they were able to go back to dancing. So we all went over for a dance when we were able to get the floor back and installed. And this is just the image of the snack bar in the University of Ferrara, where again, they would have done this work over the Christmas period whenever the students weren't on campus. And so it's a much larger installation, and they had two different types of material in there because they had a heating and a cooling requirement in the building. And then externally then we had our heat pumps. So the innovation around this was looking at the vertical heat exchangers in the ground. So in terms of the demo site in Westport, we had a very small area surrounding the building itself. So there was no option really for us to use the horizontal loops that we would have in the ground for these types of heat pumps. So we went with the vertical heat exchangers. Here you can see them. And then very quickly they were covered over, and you wouldn't, if you're there now, you would never know they were in the ground, apart from a very large manhole at the back of the centre that allows us to get in to make sure when things go wrong, we're able to get in and access and for fixing. So this was a small site in Westport. The one in Ferrara was much bigger. So they had multi-source heat pumps here. Really what their need is much bigger and much more complex than what we had in Westport. They have heating requirements, cooling requirements. There's our CPC, our PV panels that we shipped over from Trinity. They're installed in the wall there. There's very long stories behind most of the elements of this project. It happened in the middle of COVID, so but we just don't have enough time to go into those. So these were shipped around the time of COVID, so there was long periods of delays around that. But essentially, you can see that this is the campus installation. It has the control systems in place. It has the very large storage tanks there because of the demand and the requirement for energy on that campus building itself. They also installed the vertical heat exchangers in the ground around the snack bar, but many more than what we would have. So there was, over 40 went down into the ground around the snack bar, and that was to facilitate the demand for energy that was needed within the building. So in the summertime, it's the heat pumps reversed for cooling, and in the winter, obviously, then it's for heating. So you can see the different coloured panels there on the floor, and that's essentially the two different temperature ranges of the phase change material in that latent floor. So what it's doing is it's using the heat from the heat pump. It's then putting it into that the latent floor, the underfloor heating system, and that's allowing it to work for much longer periods through the day. So essentially, it's increasing the efficiency overall of the heat pump system too. And then also what they found with the solar thermal system there, the solar thermal component of the system, is that they're using that as a preheat at some points through the day and through the year. And so the fluid that's circulated in the solar thermal system is then used as a preheat to the fluid for the ground loop before it reaches the heat pump. So this is then increasing the efficiency of the geothermal system by reducing that sort of temperature differential between the ground and the fluid, which can then improve the performance of the heat pump. Also, by creating some awareness of the project around the campus too, it's trying to tell the students and the people on campus essentially how their energy has been generated to try to reduce their overall demand as well. So trying to create this awareness around energy and energy use in buildings has become a really important part of the project there too. So then lastly, it's this intelligent control part. So while we have these innovations around the different technologies for the project, the fundamental and the critical component then is actually how do we get them all to talk to each other? And that's where this central automation unit. So what it's doing, it's trying to look at how this sort of energy can be optimally dispatched because we have this locally generated energy from renewables, but how can we match that to the existing demand? So first of all, what is the current local generation capacity? So what's the solar resource at the moment? And what's the temperature in the ground? What is the possibilities in terms of energy generation? And then how can we match that with the demand? Is the resource, is the energy available, but actually the demand is low? How can we store that, and how can then it be moved into the latent, the underfloor heating essentially with that phase change material? So it's trying to look at how we can manage our energy use at the moment, day to day, but also how we can look to future and how we can predict the energy demand in the future, and also the energy generation in the future. So it's really trying to be really flexible in how we're able to move between those different systems, how we're able to feed that solar thermal excess energy into the heat pump if it's needed, how we can then feed it into the underfloor heating if it's not. And this is all done through this this automation and control system. So you can see that the grey one there is the sort of the view that we would have, and we're trying to develop the app now that will create a much more simplified version so that it doesn't really frighten people away and actually encourages them to use this type of system in terms of optimization. So really that's an overview of the project. If you have any questions on the details of the technologies around that, we have some more information on the website there. And feel free to contact me as well, of course, on that. And just to end, I'm sure John will be sending you around the information on some of the courses, but what we have in sustainable energy, we have anything from masters to postgraduate diplomas, and then our new micro-credential that we have in solar and in low carbon power. So just to end, just to say thank you very much for spending your lunch hour with me, and I'll hand it back to John now.
Thank you very much, Sarah, and thanks for sharing those details. Yes, we'll share anything you recommend alongside the recording details to anyone that's registered or participated today. So thanks for those details, and we'll share them in addition. Thank you everyone for joining and kind of completing part 1 of the series. You know, we're trying to share what people do in terms of our research and teaching. This is just an overview of part 2, starting next week until Wednesday, 5th of April. Our colleagues in natural sciences, applied sciences, and in chemistry and geography, various different disciplines and schools and faculties coming to contribute. So we've moving beyond School of Engineering and my work of colleagues from part 1, and very much hope you can join us for a very engaging range of second round speakers, and all available on the website, with next week's talk from our Vice Provost in the University, Professor Jane Stout, talking about nature in crisis and how maybe the natural environment's role and place to be considered around climate action sustainability. So thank you very much, everyone. As always, we will share a recording with all of you who have registered, including those who couldn't make it today. And please do share. These recordings are made available through the Trinity YouTube channel, and we'll share those links. And also please share and sign up for future sessions. It's great to have you all engaged with us throughout the series. So Sarah, excuse me, thank you very much for joining us this lunchtime, and for everyone. And we hope to see you all next time. Thank you very much, everyone.